Securing Kubernetes applications involves addressing various network security and threat handling aspects. Kubernetes environments are dynamic and distributed, making them susceptible to a range of network-based threats. Following is a detailed view of network security and threat handling considerations for Kubernetes application deployments. 1. Network security in Kubernetes. A. Network policies. What they are: network policies are Kubernetes resources that define how pods can communicate with each other and other network endpoints. Why they matter: by default, Kubernetes allows all pods to communicate with each other. Network policies enforce restrictions to limit unnecessary communication. How to use. Define policies to allow or deny traffic based on labels, namespaces, or IP blocks. Use a CNI, Container Network Interface, plugin that supports network policies. B. Encryption in transit. Use TLS, SSL. Encrypt communication between services using TLS, SSL certificates. Service mesh. Deploy a service mesh like Istio or Linkerd to automatically encrypt traffic between services using mutual TLS. Ingress controllers. Use HTTPS for external traffic by configuring TLS certificates in your ingress resources. C. Segmentation and isolation. Namespaces. Use namespaces to isolate workloads and limit cross-namespace communication. Network segmentation. Use firewalls or cloud provider security groups to segment traffic between clusters and external networks. D. Egress traffic control. Restrict outbound traffic. Use network policies to control egress traffic from pods. DNS policies. Restrict DNS resolution to approved domains using tools like Core DNS or Node Local DNS. E. Ingress traffic control. Ingress controllers. Use ingress controllers like Nginx, Trafic, or HA proxy to manage external traffic. Whitelisting. Restrict access to specific IP ranges or geolocations. Rate limiting. Implement rate limiting to prevent distributed denial of service attacks. 2. Common network threats and mitigations. A. Denial of service attacks. Mitigations. Use rate limiting in ingress controllers. Deploy auto-scaling to handle traffic spikes. Use cloud provider distributed denial of service protection services. B. Man-in-the-middle attacks. Mitigations. Use TLS, SSL for all communication. Implement mutual TLS using a service mesh. C. Unauthorized access. Mitigations. Use role-based access control to restrict access to Kubernetes resources. Enable authentication and authorization mechanisms, example, OpenID Connect, lightweight directory access protocol. Use network policies to restrict pod-to-pod communication. D. Data exfiltration. Mitigations. Restrict egress traffic using network policies. Monitor outbound traffic for suspicious activity. Use encryption for sensitive data in transit. E. Container breakouts. Mitigations. Run containers as non-root users. Use security contexts to drop unnecessary capabilities. Apply AppArmor or SecOm profiles. 3. Best practices for network security and threat handling. A. Defense in depth. Implement multiple layers of security, including network policies, encryption, and runtime protection. B. Least privilege. Restrict access to the minimum necessary for each component or user. C. Regular updates. Keep Kubernetes, container runtimes, and dependencies up to date to patch vulnerabilities. D. Continuous monitoring. Deploy monitoring and logging tools to detect and respond to threats in real time. E. Security testing. Perform regular penetration testing and vulnerability assessments. F. Incident response plan. Develop and test an incident response plan to handle security breaches effectively. By implementing these network security measures and threat handling strategies, you can significantly reduce the risk of attacks and ensure the secure deployment of Kubernetes applications.